Hi everyone. In today's lesson, we're going to talk about SOHCAHTOA. So if you haven't already done so, please log on to Delta Math and log in to the assignment that says PC SOHCAHTOA. And look at example number 1. I'm going to do 3 examples with you, and then you guys will be on your own to finish this assignment. So example number 1 says, find the exact value of sine of A in simplest radical form. Well, we know from SOHCAHTOA that sine is opposite over hypotenuse. So let's first circle the angle in which we're speaking about, which is angle A. So the opposite to angle A is the 14, and the 16 is my hypotenuse. So sine of A is simply 14 over 16. And then we should simplify it if we can. So 14 divided by 16, I believe we can divide the numerator and denominator by 2. So we would get 7 over 8. And that would be our final answer. So you notice how this one says find the exact value, but in simplest radical form. There are no radicals needed, so you'll just type in the 7/8 into your Delta Math, and that'll give you your green check mark. All right, let's try example number 2. Okay, so in this problem, they're asking you to find the value of cosine of A. So again, we're going to circle the angle in which we're speaking about. Cosine, remember, is adjacent over hypotenuse. So 7 is my adjacent side, and 50 is my hypotenuse. So if I want to find cosine of A, I'm going to just say that it's 7 over rad 50. But mathematically speaking, we're not allowed to have radicals in the denominator of a fraction. So if you put this into your Delta Math, it would mark it wrong because it's not technically simplest radical form. So there's a process called rationalizing the denominator that will allow us to make this radical in simplest form. So what we do is we notice that there's a radical here on the bottom. And the trick is that we're going to multiply this entire fraction by radical 50 divided by radical 50, which in all actuality, anything divided by itself is 1. So I'm really only multiplying this fraction by 1. It's just a different form of 1 that will allow us to make our simplest radical form. So how to simplify this? Since we're multiplying 2 fractions together, we multiply tops with tops, bottoms with bottoms. So remember, when we multiply radicals, it's the same as multiplying it with, say, x's. So say I have 7 times x, we would just make that 7x. So in this numerator, how I have 7 times radical 50, it's just 7 rad 50. So this numerator is 7 times radical 50. Now the denominator works a little different, where I have radical 50 times radical 50. So what we do here is we would multiply the outside numbers, which since they're not here, they're 1s, so 1 times 1 is 1. And then we multiply the inside numbers, 50 times 50. So if you type that into the calculator, you're going to get 2,500. And that stays on the inside. So inside times inside gets here. Now, I'd actually like everybody to pause the video for a second and type this into your calculator. You should get a nice whole number. So pause the video until you've done so and then hit resume. Okay, so the top stayed 7 rad 50, and in your calculators, you should have gotten 50. Anyone want to know why? Well, what does it mean when I take something and multiply it by itself? Doesn't that mean to square something? So if I take radical 50 and square it, don't we remember from the radical unit that a square and a square root will cancel each other out? So the answer will come back to be 50. So now we've successfully got rid of the radical in the bottom of a fraction, and this is my simplest form. So here is my final answer. Go ahead and type this into the Delta Math just the way you see it, and that should give you your nice green check mark. All right, I think we should practice just one more of these rationalizing types before I move on to example number 3. So let's just say you had the same scenario. You had to find tangent of something. So say you had to find tangent of angle A, and you got it out to be 5 over radical 3. And we say, put it in simplest form. So again, to rationalize the denominator, you take the denominator and multiply the top and bottom by that denominator. And then we multiply straight across. So 5 times rad 3, and then rad 3 times rad 3. So the tops will be 5 rad 3, and the bottom, rad 3 times rad 3, is rad 9, which reduces to 3. So this answer would be 5 rad 3 over 3. Okay, so that's it. That's the concept of rationalizing. Let's move on to example number 3. Okay, so example number 3 is asking for the exact value of tangent of A. So we know that tangent, sometimes I write TOA like this, opposite over adjacent. So angle A is here, here's my opposite side, and here's my adjacent side. So tangent of angle A is opposite, rad 75, over adjacent, which is 5. Now, notice how the answer says simplest radical form. That means something must be simplified. So if you look in the numerator, radical 75, you actually can probably break that up a little bit more. So if you're unsure of the factors of 75, you can go to the y equals and type in 75 divided by x, and you can look at the table of values. And when you do so, you should get 1 in 75 and 3 in 25 and 5 and 15. And the goal is to find the largest perfect square. So I see 25 as a perfect square, so 3 and 25 is the pair that I'm going to use. So I'm going to break this up into good house, bad house. So the good house, I'm going to put 25, and the bad house, I'm going to put 3. So I can break down the square root of 25 a little bit more. That gives me 5. And then the radical 3 just stays. So if I simplify this final answer, it's going to be 5 radical 3 all over 5. Now notice these outside numbers are actually divisible by each other. So we can actually divide those out. So the 5's can cancel. Any outside with outside can be simplified. So this final answer will be radical 3. So tangent of A in reduced simplified form is radical 3. So go ahead and type in radical 3 into the delta math, and that should give you your green check mark. And just before I end, I just want to make one point. Notice that the radical here is in the numerator. I did not have to do what I did in the last problem. I didn't have to multiply top and bottom by radical 75 because the radical was in the numerator. So the only time we have to get rid of the radical is if it's in the bottom of the fraction. So that's really important, and I actually like us to write that down, and then you guys can go on and finish the delta math for the rest of the class. Okay, so rationalizing the denominator, so we use when there's a radical in the denominator, not the numerator, okay? And what are we doing? We are multiplying top and bottom by the denominator itself, or by the radical in the denominator. Okay, and then last but not least, we're going to simplify. So take a couple minutes, finish the delta math, and whatever questions that you have, feel free to ask me tomorrow in class. All right, have a good day.